Hi, how are you? I've seen a couple of undefineds in terms of emojis, finger emojis. No. So my name is Maximiliano. Maximiliano is good as well. We are from the world, so if you want to use the Italian version, that's fine. So this is going to be uncovering passwordless authentication. Okay. By the way, I can go by Max as well. I know it's a long name. So let me go really quickly about myself. I'm from Argentina. I came from Buenos Aires, actually here. So I'm a mobile web developer, so I have been doing web development since 1995 and mobile apps since 2001. I author a lot of books and a lot of courses that you can find on many platforms, like Frontend Masters, Pluralsight, and so on. But today, we are here to cover one topic. And my last piece of content, in terms of content that I author, is Learn PWA. This is a free course / digital ebook on progressive web apps. And Web Authentication and Passkeys is the topic that we will cover today. It's also part of something that is on that link. Okay, so let's start. So questions, please leave it to the end. So we will see if we have time for questions. If not, I will be here anyway to answer your questions. So we know that we created HTML once in the 90s, in the early 90s, that with websites that looked like that. And at some point, someone thought that it was a good idea to also create websites that will show content only to some people, not to everyone. Originally, it was just the public web. So we created something known as HTTP Basic Authentication. I'm not sure if you remember that. It's still there actually today, where you see a login dialog that is native from the browser. So not really an HTML form, directly from the browser. But that was actually bad in terms of user experience and also in terms of security, but maybe user experience was the first problem. So then HTML forms appear at the time. So someone thought, well, maybe it's a good idea to use like a custom form in HTML and try to log in users using this technique, okay? And in this case, you all know this, I guess, that in this case, the user has a secret. The secret is the password, like, of course, your secure password, such as 1, 2, 3, 4, 5, and that's the secret. And actually what happens is that the secret is typed into the browser, and the browser is sending that to the web server, and typically the web server is saving that in a database. So that's the normal scenario, okay? So, and this is typically being done over HTTP, originally at least, and we use a keyboard to enter, in this case, the secret, the password, okay? So what's the problem? The problem is that we have two problems, and this is, by the way, all the images that you will see like this are actually from DALL-E 2 actually, so AI-generated images. In this case, the prompt was man-in-the-middle attack. Okay, so that's a man-in-the-middle attack. So a man-in-the-middle attack that it's actually one security attack that will be in the middle between two entities. So for example, here we have a possible man-in-the-middle in the keyboard, so we can have a keylogger in our computer or in our phone when you use a custom keyboard, for example. The custom keyboard is actually reading your keys. That bad actor can actually be reading your password. And also, we typically had another point of failure when we were connecting, when we were sending that password over HTTP, right? Because someone in the middle, for example, here in a public Wi-Fi, can actually get your password. And probably you know the solution for the second one, because now we are seeing a lot of websites over HTTPS. And if you have a form, and mostly if you have a login form, that is on HTTP and not HTTPS, you will see a lot of warnings saying that, for example, this is a not secure URL, or be careful, the information you're about to submit is not secure, blah, 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 blah. So you know that we all need to serve websites these days over HTTPS. So we are actually solving that problem. So with HTTPS, man-in-the-middle attacks here at least are not a problem anymore. But that doesn't mean that we don't have problems. So we still have bad actors, for example, that can read passwords server side. So they can attack web servers, and we know that happens every day, where password and credentials appears leaked in a lot of forums, okay, because they are attacking web servers and they can get your passwords. They can be hashed, but it depends on the mechanisms that you're using. That hash can be guessed as well. Also, there are a lot of breaches, data breaches right now, and there is a good chance that all your passwords were already leaked at least once. I'm not sure if you have seen this website before, Have I Been Pwned, and you can enter your email address and it will tell you all the passwords on every website that actually has been leaked. Apparently you have seen that both Apple, Firefox, and Chrome, now they are giving you hints if you have passwords stored that are insecure. So they will tell you, hey, that password was compromised, so please go and change the password. And we still have that problem there, so that problem is still there. That means you installed something in your phone, you install something in your computer that comes with a keylogger, or it cannot be, it can be other things, a plugin in your browser, something like that, that can actually be stealing your password, your secrets. So then we have that other guy that it's actually brute force. And by the way, you will see that most of these guys are men, actually all of them. I mean, based on AI generation. But brute force means that even if your password is hashed, or even if no one is actually attacking a server, so someone can try passwords on your websites, and they can maybe guess your password. So that's why we get so complicated that we need to get a master's degree sometimes to understand how to create the password, okay? So, in fact, we lead to something like this. Passwords are getting so complicated that sometimes, this is a Wi-Fi password, I think it was in Nantes, France. So it's impossible to actually type that, okay, but to understand that. But it doesn't even fit in a piece of paper. And talking about papers, passwords were getting so complicated that people are actually today writing passwords in paper, which leads to a lot of problems. For example, and this is a real picture from in Buenos Aires. This is a shop. I think it was you already seen that, right? So, it was a bakery. So what's going on here? Well, they have their Wi-Fi password there, but also they have their password there that is admin, by the way, but it's also written in a Post-it. Okay, and I was taking the picture from the consumer side. Okay, so we know that that's a problem. Also, we have this guy that is actually making phishing over the phone. So he's calling you and scamming you over the phone to give you the password for something. They're calling you from the health ministry or whatever. Okay, things like that. So that's also from Buenos Aires. It says in English, I'm not in Lithuanian, but it says that the bank will never ask you for the password. Okay, so actually, I don't even like the message because so then if I go to the bank, I need to type my password. But anyway, or if I go to the website, okay, and it says passwords are not shared. Do not share the passwords. So we have to do these things because people are giving password over phone. So then we lead to another solution, and that guy is actually a password manager. Okay, things like that LastPass or 1Password, but then also they can be hacked. Okay, they had an issue and they hacked all the passwords. It's encrypted, but if you have a very low secure master password, then they can get all your password at once. And even we have phishing. What's going on with that URL? That's not paypal.com. That looks like PayPal, but it's not PayPal, and then you enter your password manually there, okay? So even if it's secure, you probably know all these things. So probably, I'm guessing, that you enable two-factor authentication. That's two-factor authentication, right? So, and when you enable that, it's actually so complicated these days that it's not just two-factor, it's multi-factor. So for example, on Google, you can add passkeys, we will talk about that later, password, security keys, authentication, Google prompt, two-step, blah, blah, recovery phone, recovery email, Google account PIN. So it's a mess, okay, to actually log in into systems these days to make them more secure. And then we have that other guy, but we don't know if it's a guy or a girl actually, but that's SIM hijacking. Actually, it happened to me that I used to have, before the pandemic, I used to have a SIM card from US, so I have a European SIM card, the Argentinian SIM card, the European SIM card, and an American SIM card from USA. And I remember one time in USA, my SIM card didn't work, so I went to the office, to one of the, it was actually T-Mobile, so don't tell T-Mobile, but I went to the office, to one shop, and asked for another SIM card. And they said, what's your phone number? Okay, I gave them my phone number, and they gave me a new SIM card. No ID verification. Okay, so if you're using SMS, that's another problem. We have something like that, so someone has compromised a security minister in Argentina just by doing that. They clone the SIM card, and then they get into Telegram, I think not WhatsApp, but Telegram, of one of the government officials. So we have two conclusions here, okay, so far. So I'm not sure if you realize, at least from an AI point of view, that all bad actors are using hoodies, okay? So we shouldn't be using hoodies, okay? That's the first thing, the first conclusion. But that's not the important part. We shouldn't be using passwords anymore. The problem here are passwords, okay? But the next question is, okay, how are we going to do this? How are we going to replace passwords? Well, say hi to Passkeys. This is the solution, Passkeys, okay? It's passwordless authentication. The term is Passkeys. So in the future, we will never talk about passwords anymore. We will be talking about Passkeys. And when in the future, it's up to us, because it's something that you, or we actually, need to implement in our websites and apps to actually make this happen. So let's try to understand Passkeys. So with Passkeys, this is the structure. We have the user, the browser, the server, and the database. That's the same. But in this case, the secret is not something that the user knows. It's not a password. It's something that the user is or the user has. Is because it's me, so it's my face, it's my finger, or something that I have that can be a USB key or a phone. It's something that I have, okay? Not something that I remember. I don't need to remember passkeys, okay? So, and this is how it works. We have first, there are two keys, so this has to do with cryptography and private and public keys. So in this case, there is a system, I don't have enough time to get too deep in the details, but actually there is a system in the device or in the browser that will generate a pair of keys, a private key and a public key. The private key is stored safely somewhere, where it can be hardware-based, it can be in the phone, it can be in iCloud on Apple, it can be in your Google account, under Google management, on Android or Chrome, for example. Somewhere it can be a USB key, and the public key is in the browser. You can actually see the key in JavaScript. It's a public key. And we are going to send to your server the public key, and you will store in your server the public key. And I'm not sure if you are aware of how these keys work, but actually when you encrypt data with the public key, you can only decrypt it with the private key, and kind of vice versa. I'm simplifying this. But that's the idea. So it's a two key mechanisms where you cannot actually encode data with the public key. You can use the public key to decode data. Okay, does that make sense, kind of? So this will solve a couple of problems. So for example, trying to see why, there we are. So if someone is attacking, if a bad actor in hoodie is attacking a web server, actually the only thing that that person will get is a list of public keys that are completely useless. And you can say, well, but what happens if that bad actor is creating a phishing website? Well, actually, something that I didn't tell you yet is that passkeys are origin-based. So the passkey that we created is only for that website and that origin. So actually, the browser will check the origin. And if it's not paypal.com, it cannot use that passkey. That means that data breaches are not a problem anymore. Of course, the only thing that they can do is just change the website. Well, if they have enough power to change the website, yeah, you are on paypal.com and now it's a different website, well, yeah, they will get there. But that's not a data breach. That's actually a more complicated hack. So, or attack more than hack. What happens here? Well, for example, keyloggers, or if you have a bad application running into your device, they cannot get the private keys because private keys are encrypted by the hardware. It can be a USB key that is typically encrypted with a PIN, or it can be your phone and it's encrypted with your face or with your fingerprint. So that means that no one can actually steal that with a keylogger or with just an app. Also, typically, for example, on some mobile devices such as iPhones, that information is not stored in the standard memory. It's stored in a separate place. I'm talking about the face recognition system. So that means it's even more secure. Of course, nothing is 100% secure. Okay? We are actually moving towards something that is much better. Because now we are removing not all, but most of the issues that we have with passwords. So let's try to understand this better. Passkeys first is an end user concept. The idea is that you go to a website and you will see sign in with passkey. So we will use the word for the end user. Okay? Technically, for us, for developers, it's the Web Authentication API. That despite the name web, it's a web spec, so it's coming from the W3C, but it was created also with the FIDO Alliance. That means actually that it's not just web, it also has to do with hardware situations, and we have also native APIs, for example, for Android or iOS native apps, which actually use web authentication as well. So it's not just JavaScript based, okay? It can be used for multi-factor authentication, so you can still have passwords if you want, and then you can add a passkey as a second authentication step. For example, if you remember the Google screenshot that I showed before, they have passkeys as a second factor authentication possibility. So you can add your face or your fingerprint recognition as a second factor authentication apart or in addition to your standard unsecure password. But also it can be used directly as a single factor authentication. How many of you have a GitHub account? Most of you, right? Do you know that now you can log into GitHub with passkeys as a first or as a single factor authentication? You don't need your email address. You just use the passkey. Okay, I will show you later how that works. So in this case, it's a single factor authentication. So then think about for those of you that are creating backend solutions or databases, you don't even need to store a password anymore. Or even a username. Typically it can be a completely identifier-less solution. The passkey is the user. You don't, unless you actually need to identify the user with email or with a passport number or something like that, it can be a completely anonymous login. The passkey is the user option. Keys, the private keys, can be stored in the device, on external hardware, or even in the cloud. It depends on the browser, it depends on the platform. I will show you compatibility in a second. So the current status of websites using techniques, and here we are going from less secure to more secure. So Passkeys is kind of the goal. Form-based authentication, so standard forms with passwords, are the less secure, but it's where we have more websites these days. In the middle, we have multi-factor authentication, and you have multi-factor authentication with web authentication. So multi-factor can be SMS, but as I mentioned before, I mean, yeah, you need to go to an office, there is a camera, the police can actually investigate that, but it can lead to problems. With if you use web authentication as your second factor authentication, it's more secure because it means your face, and it doesn't work with a picture. Okay, so there are some securities on top of that. So web authentication is a multi-vendor effort. So it's not something from Google or something from Apple. It's multi-vendor. It's between the FIDO Alliance, there is an alliance for security and hardware. YubiKeys, for example, are part of the FIDO Alliance, and the W3C. It will store safely private keys while sending public keys to the server only. And it works with FIDO2, that's a specification. And it can be, for example, a hardware key that can be NFC and Bluetooth based, or it can be directly a platform authentication. And that is, for example, Touch ID, Face ID, Android biometric authentication, Windows Hello on Windows, for example. So that's a platform authentication. It works on every browser today, every browser, with different techniques and ability based on your hardware. So they can be pin-based keys, it can be a USB key, such as the Ubico keys, or the biometric authentication, as I mentioned before. And it works on every browser, on every operating system today. It works on Firefox, Safari, Chrome, Edge, Android, iOS, iPadOS, Windows, Mac, Linux, and Chromebooks, Chrome OS as well. So the idea is that we have a reliant, this is the image actually from the W3C. The relying party is actually us. The relying party is the server, the web app, the website, or the native app. Then we have the web authentication API that talks to the client. The client can be the browser, the platform that can use an internal authenticator or an external authenticator. And it's a simple diagram. It gets more complicated. Okay, I have 2 minutes to actually show you this. So this is how it works. First, let me actually do this. First, the user goes to the relying party. So the user opens your app. The user goes to your website. That's what it means. So there, you use login with web authentication. I know that at this point, you don't understand exactly the difference between passkeys and web authentication. But let's say that they're kind of the same thing. One term is from a user's perspective, passkeys, and the other one is from a developer's perspective, from an API perspective. That's WebAuthn, or web authentication. So in this case, after the user goes to the relying party, the user will choose there to log in without password. So the next step, the website will ask the authenticator to use the key pair. So the authenticator is just a process in the browser or in the platform that will create the pair of keys. It will store safely the keys. Actually, before that, the user needs to use a gesture to authorize the use of a key. For example, if I go to your backpack and I stole your USB key, it's not going to work automatically because that USB key needs a gesture. It can be a pin. I mean, if it's a phone, it needs my finger, it needs my face. It's not just, oh, if I get your unlocked phone, then I can create private keys for you. No, I still need your face or your finger. So after the user has authorized that for that website, remember, this is per website. We don't share keys on different websites, then we have a pair of keys. So the authenticator will sign a response with a private key. So there is a response. The response is signed with the private key. The private key is in the authenticator. It never leaves the client. And then the website verifies the signature with public key and then logs the user in. I will show you a demo in a second anyway. So this is in webauthent.me, M-E, you will see the current compatibility based on the browser in terms of which, in this case, it's talking about roaming authenticator that they can connect your device in many ways, USB, Bluetooth, or NFC. I will show you this in a second because there are a couple of questions. For example, what happens if I'm in the hotel, let's say I need to go downstairs, I want to print my boarding pass, and there is a printer, there is a computer, and I need to log in into my account on that computer that is not my computer. How can I use a passkey? We know how to do that with a password. But if the passkey is here on my phone, it feels like it's not going to work. Well, yes, it's going to work. And I will show you how in a second. The web authentication, the passkey system, will let me use a QR code plus Bluetooth to actually log in with a passkey that I have on my phone in a computer. That can be a different browser, and it can be a different operating system completely. This is platform authenticator. Platform authenticator are actually the ones that are using your biometrics to log in the user. Okay? So, for example, this is Best Buy in US, where they have now the sign in with a passkey. And you can see that sign in with a passkey is not part of the normal form. It says sign in with email and password or sign in with a passkey. So that means that with the passkey, you don't need a username. I don't need your email. I just need your passkey. Okay? And when you do that, this is the diagram that appears. Don't worry, I will show you one live in action in a second. I'm not sure if you recognize the UI. That's GitHub. So as I mentioned before, you can go to github.com today, and then first you need to log in normally with username and password, and you need to add a passkey to your GitHub account, so then you can create passwordless sign-ins. And the next time, then you can log in into your GitHub account without your email, just with your passkey, and without the second factor authentication. Because with the passkey, we don't have all those problems with hoodie-based bad actors trying to steal my account, so then when you use a passkey, you don't need a second factor authentication, so it's faster. So you add the passkey, okay, and then you're done. And let's say from the beginning of this year, now we have most operating system, mobile operating system, supporting cloud-based passkey support. So what is that? In this case, it's available on iOS and iPadOS since iOS 16, so that's from last year. So we've been a year and 2 months, or 14 months since it was released. macOS from version 13 using Safari. Other browsers coming on macOS. Actually, on macOS 14, other browsers can use passkey, but it's not yet implemented by a lot of browsers. Android from version 9 are supporting passkeys. And Windows 11 from version 33H2 that appeared a couple of weeks ago, 2 months ago, or something like that. So all these, so before this, you can use passkeys, but not cloud-based. So what's the point of having cloud-based passkey support? That then, if I create a passkey on my phone with my face, I can then use that passkey on my Mac with my finger. Okay, without actually sharing the passkey manually. Because it's the same iCloud account, it doesn't matter if I'm authenticated into the system, it's going to work. Or on Chrome, you can use Chrome on Windows, and you can also use Android and Chrome, and you can use finger fingerprint on Mac and Android. Does it make sense? So you can create a passkey that is only for that device, or now you can create a passkey that will be stored in the cloud and share between all your devices. So, and passkeys, it's the new DNA of Web Authentication. Web Authentication API is not new. It's been for almost 5 years. Not on every browser, but kind of. But passkeys is the new DNA. What's the idea of passkeys? To use Web Authentication as a first factor, not for multi-factor. So the ideal future is that when you get into a website, you will never see a login form again. You will just see passkey, button for use a passkey. That's the ideal. And that will remove a lot of security issues that we have today on the web. So authenticators on passkeys are saving the keys in the cloud. So you can use them on different devices, we already mentioned that. And even you can share them with other users, for example, in the family. Apple lets you share with your family passkeys as well. So you can share your Netflix passkey in your family. For example, for your iPad key, the iPad for your kids, something like that, okay? And also, now there is this is for those of you that are web developers, there is, or even UX designers, there is something known as a conditional UI. Conditional UI will let the browser autocomplete a login form, a standard login form, with a passkey. Let me tell you what that means, and I will show you one example in a minute anyway. You have a standard login form, because right now we are not yet in that future. Okay, we are in the middle, so we still have login forms. And well, when you click in the username or email field, the browser can autocomplete, in the suggestions that you get, your passkeys. So instead of typing a username or selecting a username from the list, when you click in the username, the suggestions can be directly passkeys. And if you select a passkey and you authorize the passkey using your finger or using your face, it will log in without typing the username. Okay, that's the idea of the conditional UI. So advantages, this is phishing resistant, because no matter if you're calling me and scamming me over the phone, I cannot give you over the phone my passkeys. And even if you give me a URL that I need to go and use my passkey there, it's not going to work, because passkeys are origin-based. So if you can get my passkeys, they're completely useless. If you can get the public key, they're useless. They are unique per service, as I mentioned. It can be an app or it can be a website. And it's data breach resistant, because if there is a data breach in a company, it doesn't matter. They won't get the passkey. They have only the public key. And they cannot even use them for a phishing website. So that's why this is much better. And also, it can give you today quicker, more secure access on all your devices. And even this is compatible with PWAs on iOS. So I'm not sure if you have installed PWAs on iOS, or if you know what that is, but when you install a website that is an app, and cookies or local storage are not shared. This is changing right now, but typically they are not shared between Safari and the app. So you are logged out in the app. Well, instead of logging in the user with username, they can just use the face, and immediately they will get in. So, important actions here, it says that you can use on-device authentication. That is, I want to log in my phone, and I'm using Face ID from my phone. Or remote authentication. I want to use the computer from the hotel lobby, and I have my passkey here. That's known as remote authentication, okay? And you can share passkeys on trusted contacts. What do you need? 4 web services. 4 web services? Yeah. 4 web services because there are 2 services for registration and 2 services for login, for authentication. So think about if you're doing web services, typically you have login, registration, and login, 2 services. Well, in case we need to create 4. because there is a process that you send the key, you need to save something that goes back. There is a process there. It doesn't matter at this point, but that's something you need to implement. Then you need to implement the Web Authentication spec server side. The libraries for Python, Node.js, Java, .NET available, so you don't need to do it manually. Implement also the Web Authentication API client side. And then you will store now n credentials per user, not one password. So the relationship between users and passkeys is 1 to n. You may have more than one passkey per user as well. And you need to make a decision these days. Use passkeys for multi-factor authentication or for single-factor authentication, or both. GitHub, for example, has both options. And maybe for the future is to create the idea of passkeys as a single-factor authentication without even a username. The passkey is my user. So it's completely anonymous from that point of view. Okay? So let's stop talking and see this in action. So there is a website that you can try on your own. You can try on your phone if you want. It's passkeys.io. Passkeys.io, simple to remember. Here, you can try this. So it says sign in with a passkey, okay? So I can click sign in with a passkey, and I'm in Safari on the Mac. It says, hey, do you want to use Touch ID to sign in? And also, instead of using Touch ID, there are other sign-in options, really small there, but it's there. Other sign-in options. And if you click there, you can actually use a security key, a USB key, or an iPhone, or an Android device, in case you have the key there. And let's try again, sign in with a passkey. I will use my finger. Done. And it says, oh, this passkey cannot be used anymore. What happens here? The idea is that this website will register. So if I use an email here, let's say hello@billstuff.com, wherever. So it says, oh, do you want to create a new account? Okay, let's create a new account. So I'm going to create a new passkey. So I'm registering this. So now I'm creating a new passkey. With my finger, I have just authorized the creation of the passkey. So I can add my email. I can create more passkeys to this account, okay? And I can sign out. And now I can try to sign in again using my finger. And now you can see I have 2 credentials. So this one was actually removed from another conference. This one was removed from the server because it's just a testing server. So now I have 2. So that answers the question that no one asked yet, that can I have more than one passkey per website? Yes, you can. In this case, I can now log in with my second password. And I'm in again. And the same happens if you use Google Chrome or Firefox, okay? So I can sign in with a passkey. It's a different UI because it's a different browser. But first it says, do you want to choose, I can choose a passkey from the iCloud keychain, from a phone, an Android phone that I have, or to use a different phone that you may have. If I use iCloud keychain, now I'm using the same, can you see the same dialogue? So I can use the hello@billstuff.com. I will put my finger here. So now it's kind of Safari is sharing the passkey with Chrome. Does it make sense? That's what's going on here. So from a user perspective, it's that. So it's that simple. Now let me show you GitHub. So I'm here in Chrome Canary. Okay, so in Chrome Canary, this is the alpha version of Chrome. By the way, it has a different UI now, different tabs, design. But I'm not logged into GitHub here. I've never logged into GitHub in this browser. So you can see that I have the standard form, the username and password, and also I have a sign in with a passkey. And if I click here, let's say that I don't have it in this computer. I have it on my phone. So I will say, I want to use a phone. So I have a QR code. And I know that you are thinking, hey, you want to take your phone now and log in with your GitHub account using the QR code. Or for those of you watching the video, maybe you want to log in into my computer from your home using the QR code. It's not going to work. So I'm going to do that first. Sign in with Passkey. You don't see that, but you can see it says sign in. I have a dialog, and it will ask you for my face at one point. Why it's not going to work for you? You can see it says connecting to your device, and now I need to use Face ID to confirm that, and now I'm in my GitHub account. For the first time in this computer, no second factor authentication, nothing. So it's not just about the QR code. The QR code is the initial part. Then you need Bluetooth. And it checks how far are you from the device. Maybe she can log in, because it's fair enough, but not from the back, and not remotely, because it needs a physical Bluetooth connection to actually finish sharing that passkey. So the QR code is just the one that initiates the process. I don't need to select the Bluetooth. The only necessary part is that you need to have Bluetooth enabled on both devices. And then you can use a phone to log in into the computer, or vice versa. In this case, it's sharing. And now, does it mean that now I have that passkey in my browser? No. If I log out, or if I come tomorrow and GitHub already revoked my session, I don't have the passkey on this computer. I need to log in again, remotely or not. Okay? Does it make sense? So that's Passkeys. Okay, so that's how passwordless login works. So that's my last slide.
Thank you very much.
Questions?
Do we have questions, right?
Questions?
Yes, please.
I wanted to ask how the recovery will work if I have it on external device and it's lost or broken. How we can?
So if you have, so your passkeys are on an external device and the device is broken.
Yes.
Well, in this case, you don't have the passkey anymore, so so you don't have that passkey. So the solution to that is that first, as far as we understand, only special users will get into that situation. Normal users will just use iCloud and Google account, and they won't use hardware keys. But anyway, so then you need a process to, the same happens today if you lost your password. You need a process to let that user to identify somehow offline to create a new passkey. There is no solution for that, because it's like losing your hardware key where you have your Bitcoin wallet. Okay, what happens if you lose that? I'm sorry, but you're poor now. So something similar will happen with passkeys. Yeah.
Thank you.
I have seen other hand, but I don't know where is it. Oh, perfect.
You mentioned earlier that passkeys are mostly safe. So what threats do passkeys face?
Well, compared with passwords, it's 1,000 times more, safer. So you still have a problem if, typical problem, someone is here with a gun and is asking me to put my finger. Nothing that we can do about that, right? And then if you're using the share solution, we have the situation that it's not so common, but it's not impossible, that someone can hack into your iCloud account. That is not simple, but it happens. That, for example, there were research saying that if someone is stealing your phone and they can guess or get, for some reason, your PIN, they could reset your iCloud account and they can register another finger, another face. And if they do that, then they can use your passkeys. Okay? So that's why the recommendation for those of you on iPhone is to change your PIN to alphanumeric, not numeric. So to use, so not a numeric PIN, but an alphanumeric PIN. That is possible. That will increase that problem. But those are the most common situations. So data breaches, it doesn't matter. Trojans or bad apps that you can have in your computer, no, it's not a problem at all.